Hi everyone, welcome to the second half of section 6.3. We're going to continue talking about binomial radical expressions. And now I want to talk about conjugates and how they can be useful in dealing with radicals. They were really useful earlier when we worked with complex numbers, if you will remember, and we had to rationalize denominators, get rid of those imaginary denominators, and also even just how to get rid of just imaginary numbers. And we found out how kind of magical conjugates were. The same applies with radicals. So the conjugate of the square root of a plus the square root of b is the square root of a minus the square root of b. Just like the way conjugates were with complex numbers, exact same with radical expressions. So look at these two conjugates, 5 minus the square root of 7 and 5 plus the square root of 7. And let's FOIL this just to remind ourselves how conjugates work when we are FOILing and multiplying. So we'll start with 25. This is positive 5 square roots of 7. And this is negative 5 square roots of 7. And this is negative square root of 49. Right, when we simplify, notice these two middle terms, because they are opposites, cancel each other out, and they end up being 0. And then this is square root of 49, which is just 7. So we have 25 minus 7, which is 18, and our radicals have disappeared. That's what's wonderful about these conjugates. So if you look at the pattern, we have our a term squared minus this b term squared ends up being our answer. So a squared was 25 and b squared was 7, so it's 25 minus 7 or 18. That's the pattern that we see with conjugates. Let's do it again with another conjugate. 6 minus the square root of 12 and 6 plus the square root of 12. So we'll go a little bit faster. We'll start with these two squared, which is 36. And I know this is going to be positive 6 square root of 12 and negative 6 square root of 12. So therefore, I'm not even going to write those. And then minus the square root of 12 times the square root of 12, which is 12. Right? Actually, it's the square root of 144, which is 12. But realize when you square the same square root, you just lose the radical box. So 36 minus 12 is 24. And we've done it. One more, just for good measure. 3 plus the square root of 8. 3 minus the square root of 8. Let's FOIL this. 3 times 3 is 9. Negative 3 square root of 8, positive 3 square root of 8. We're going to disappear that. This is minus, and the square root of 8 times the square root of 8 is 8. Our final answer is 1. Now, our goal in doing conjugates, multiplying by conjugates, is to be able to rationalize denominators. You do not want a radical in a denominator. We dealt with that before when we were simplifying expressions. We have the same kind of situation now when we are dealing with binomial expressions, same thing. So how do we rationalize now? Because now we have two square roots. We can't just multiply by the square root of 5 or by the square root of 2. That won't work. So what we need to multiply by is the conjugate of this binomial. Since this is the square root of 5 minus the square root of 2, its conjugate is the square root of 5 plus the square root of 2. So here I've set out to rationalize my denominator by multiplying by its conjugate, but remember, I have to multiply the numerator by the same thing, so that in effect, I'm only multiplying this fraction by 1. So I also have to multiply my numerator by the square root of 5 plus the square root of 2. Let's go ahead and let's start with our numerator. So we are going to distribute 3 square root of 2 into both of these terms. So 3 square root of 2 times square root of 5. Remember, it's number times number, radical times radical. So 3 times 1 is 3, and the square root of 2 times the square root of 5 is square root of 10. So that's 3 square root of 10. This is a positive 3. 3 times 1, square root of 2 times square root of 2 is 2. So this ends up being 3 square root of 10 plus 6. Now let's go ahead and multiply the two conjugates. Square root of 5 times the square root of 5 is 5. This is positive square root of 10, negative square root of 10. Those disappear. So this is going to be negative 2. So 5 minus 2 is 3. Now look what I have here. I have 3 square root of 10 plus 6 over 3. Notice all three of these terms can be divided by 3. Ignore this. Remember, it's just like a variable. It's this I want to care about. This can be divided by 3, so can this, so can this. So these two cancel out, and this becomes a 2. So what I'm left with is either the square root of 10 plus 2, or you could say 2 plus the square root of 10 over 1. That's it. Or 2 plus square root of 10. Doesn't matter the order, either way. That's your final answer after you have rationalized the denominator. Let me go ahead and do one more together just to make sure that you've got it, walk you through it. I have 2 square root of 7 over square root of 3 minus square root of 5. So my first step to rationalize this denominator is find the conjugate of this. And the conjugate of that would be square root of 3 plus the square root of 5. And I multiply the numerator and the denominator by the same thing. So now I'm going to go ahead, I'll do the numerator first. This becomes 2 square root of 21. And this is plus 2 square root of 35 over, this is 3 minus 5, or negative 2. Negative 2. All of these can be divided by 2. So what I have then is square root of 21 plus square root of 35, and this is negative. So both of these are negative. So negative square root of 21 minus square root of 35. This simplifies to be negative 1. This simplifies to be negative 1. So that's my final answer. I hope that made sense to you, because the last thing on our video, nice and short today, the last thing is for you to rationalize this one. So take this problem, find the conjugate of the denominator, multiply the numerator and the denominator by that conjugate, and get rid of that radical in the denominator and show me what it looks like rationalized. And that'll be your lesson check for this second half of this section. And that's it. I will see you guys next time. Have fun with this.